Good day, everyone. So, our lesson for today is about solving quadratic equation in one variable using extracting the square root. So, to start with, let us give first the different cases in extracting the roots. All right, so extracting the roots. Right? So in extracting the roots, we have three cases. So case one is if k is a constant. If k is greater than 0, then we have two solutions or roots. That is, x is equal to the positive or negative of our k. Alright? So x is equal to the positive and negative of the square root of k. That is our case 1. Our case 2 is if k is equal to 0. Then we have one solution only, or root, which is x is equal to 0. And case 3, if k is less than 0, then we don't have or no solution, right? Or roots. Again, if k is greater than 0, then our solution is the positive and negative of the square root of k. If k is equal to 0, then we have a one solution that is equal to 0. If k is less than 0, then we don't have solution. Now let's have an example. Let's say x squared minus 16 equals 0. Now, extracting the roots, we need to form it first in x squared equals k. So we need to make or put the constant on the right side of our equation. So to do that, we need to add 16 here on the left side and add 16 on the right side. So negative 16 and positive 16 will give us 0. So that will be x squared equals 0 plus 16 is 16. So now this is in the form of x squared equals k. Now to get the square root of this, all we have to do is to just get the square root of each quantity. The square root of x squared is x, and the square root of 16 is 4, and it's the positive or negative 4. Therefore, our solution set for our roots is or are x is equal to positive 4 and x is equal to negative 4. Now, these are the solutions or the roots of our equation x squared minus 16 equals 0. Now, let us check whether our solution set or our roots are correct. So, checking, all we have to do is to substitute either of these two roots in our equation, and let us check whether it is correct or not. So to do that, we are going to use both of them to really check if these two solutions or roots are the correct one. So if the value of x is 4, so that will be x squared minus 16 equals 0. So 4 squared minus 16 is equal to 0. 4 squared is 16 minus 16 equals 0. 16 minus 16 is 0 equals 0. So that is correct. How about if x is negative 4? So same, x squared minus 16 equals 0. Substituting negative 4 to our x, it's negative 4 squared minus 16 equals 0. Negative 4 squared will give us 16 minus 16 equals 0. So therefore 16 minus 16 is 0 equals 0. So therefore x is equal to 4 and x is equal to negative 4 are our solution set or the roots of our quadratic equation x squared minus 16 equals 0. Now, let's have another example. Let's say x squared plus 2 equals 2. So we need to again form it in the form of x squared equals k. So we subtract negative 2 on this side and subtract negative 2 on this side. So this will become 0. So x squared is equal to 2 plus negative 2 is 0. So this is case 2, right? So k is 0. So therefore our solution or the value of x is 0, right? It's automatic because it satisfies our case 2, which is k is equal to 0. Therefore automatic that our value of x or our root is equivalent to 0. Now let us check if our value is correct. So let's have x squared plus 2 equals 2. Substituting the value of x, 0 squared plus 2 equals 2. 0 squared is still 0. So what will we have here will be 2 is equal to 2, which is correct. Now let's have our third example. Let's say x squared plus 2 equals 0. Now, again, transform it in this form. X squared equals k. So, by subtracting 2 on both sides, so we get x squared, this is now 0, equals 0 plus negative 2 is negative 2. Negative 2 is less than 0. So therefore, it is automatic that there will be no solution in this quadratic equation. This is case 3, right? So again, if our k is greater than 0, so that is 16, it is automatic that there will be two solution set, and that is the square root of that number. And if k is equal to 0, automatic that its solution is 0. And if k is less than 0, and it is automatic that there will be no solution. Alright? So that is the different cases that we can consider in solving quadratic equation using extracting the square root. Right? So let's have another example. Let's say x plus 2 squared equals 4. Now, this is in the form of x squared equals k. Therefore, 4 is greater than 0. So, we know that there will be two solution set in this quadratic equation. So, by getting the square root, we have x plus 2. So, the square root of x plus 2 squared is x plus 2 equals the positive or negative of the square root of 4, which is 2. Now, let us separate these two equations because as we can see, we have positive 2 and negative 2. X plus 2 equals positive 2 and x plus 2 equals negative 2. To solve for the roots of our quadratic equation x plus 2 squared equals 4, we need to uh, solve for the value of x. So as we can see here, uh, let us subtract 2 from both sides. So this will become 0. So x is equal to 2 plus negative 2 is 0. So that is the first root of our quadratic equation. Next is by subtracting 2 again on both sides. So this will become 0. X is equal to negative 2 plus negative 2 is negative 4. And these are the values of or the roots or solution set of our quadratic equation. Now let us check whether these values are correct or wrong. So again, x is equal to 0 and x is equal to negative 4. And our equation or quadratic equation is x plus 2 squared equals 4. Now, let us check whether it is correct or wrong. So using x is equal to 0, x plus 2 squared equals 4. Substituting the value of x, which is 0, 0 plus 2 squared equals 4. 0 plus 2 is 2 squared equals 4. 2 squared is 4. Therefore, 4 is equal to 4. How about if x is negative 4? Again, x plus 2 squared equals 4. Substituting the value of x, which is negative 4, negative 4 plus 2 squared equals 4. So we have negative 4 plus 2 is negative 2 squared equals 4. Negative 2 squared is still 4 equals 4. Therefore, our solution set or the roots of our quadratic equation is 0 and negative 4. Alright? So, another example. X minus 1 squared equals 9. So extracting the roots. So this is our example 5. All we have to do is to just get the square root of our quantities. So the square root of x minus 1 squared is x minus 1 is equal to the square root of 9, which is positive and negative 3. So separating the two equations, x minus 1 equals positive 3 and x minus 1 equals negative 3. Okay, so applying uh, addition property or the subtraction property of inequality. So we add 1 here and add also 1 on the other side. So this will become 0. So x equals 3 plus 1 is 4. So this is now our first value of x. How about on the other side? So we subtract 1. We add 1 to remove negative 1 here. So we also add 1 on the other side. So this will become 0 now. So what we have is x is equal to negative 3 plus 1 is negative 2. So the two values of x or our solution set, our solutions or our roots are 4 and negative 2, right? So these are the solution set. Now let us check whether our values are correct or wrong. So checking, right? So x minus 1 squared equals 9. If x is equal to 4, substitute the value of 4. So that is 4 minus 1 squared equals 9. Right? So 4 minus 1 is 3 squared equals 9. 3 squared will give us 9, therefore 9 is equal to 9. How about if x is equal to negative 2? Again, so x minus 1 squared equals 9. If x is negative 2, is x negative 2 a solution set or root of our quadratic equation? So by substitution, negative 2 minus 1 squared equals 9. Negative 2 minus 1 will give us negative 3 squared equals 9. Negative 3 squared will give us 9. Therefore, 9 is equal to 9. So this is the solution, or these are the solution or the roots of our quadratic equation x minus 1 squared equals 9. So that is how we solve quadratic equation in one variable using extracting the square root. So that's it for today. I hope you learned something. See you next time and God bless.